Hi friends, in this video we'll discuss about the running executor with too much memory often result in the excessive garbage collection. It's meaning that if you're cooking some meal, okay, and if you're making it on the high flame, it will make your food burn. Okay, so you're wasting the fuel and you're wasting the nutrition. Okay, so running executor with too much memory means if your chef is using too much of fuel, it will lead to burn food. Okay, which is the excessive garbage collection. So let's take one scenario here, right? So you have six nodes means you have six what you say, six stoves. Okay, and each stove you're assigning one chefs. Okay, and the memory they are using, each stove is using 64 GB. Each stove has 64 GB fuel. Okay, and in each stove you have 16 burners. Correct, in each stove you have 16 burner, and like this you have six burners, six stoves. Okay, so 6 into 16, around 90 burner you have overall. So the number of how many number of executors do you need, how many chefs do you need, okay, to make your work parallelly? So if you use six chef, okay, and assign each chef in one stove having 16 burners, correct, so it will not be useful because only six parallel tasks can be done, right? But if we want to optimize it, let's say, uh, with these much of resources, how many number of executors can work together like a team? Okay, so how do we know that? What we're going to do is we will um, yeah, so what we're gonna do is, so let's say we will remove one core, one burner, and we will keep aside for the um, what you say, you keep aside for the backup. Okay, if everything got failed, at least you will have something. And in programming it is saved for the OS, operating system, to work on. Okay, so now you have, out of six you have five core per executors, one chef. So now the assumption is, one chef cannot work. Okay, one chef cannot work in cannot use all these 16 burner. Okay, because we have assigned one chef to one stove having 16 burners. So one chef cannot use all 16 burners altogether. He can use maximum five or six, let's say five core or five burner one chef can use. So out of 90 burner that we have seen, 6 into 15, right, out of 90 burner only 5 is using correctly currently. So we'll divide 19 divided by 5, that means 18. Okay, so um if we divide the burners, okay, and if we divide the burners, why we are doing it by 5? Because each chef can use only 5. So in one stove, how many chef can work together? Think in this way, you have 16 burner, only 5 are using, and one chef is using 5. So how many chef can use the other burners of the same stove or the one stove, right? So out of 90, or you will say 16 divided by 5, okay, at least 3 executor, 3 chef can use one single burner. So out of total 90, if we divide it by 5, at least 18 executor can run, or at least 18 chef can work all together, okay, to run the task. 18, so 18 tasks can be run instead of 6 initially. You can work like 18 tasks, you can work all together parallelly. Okay, so let's take the another scenario. um like if we talk about the memory, so one stove was, so why we are dividing it by 3 here, basically 63, So let's go back. Okay, and each node has three executors that we have seen initially. Okay, and we have the memory around 63, right? 63 GB in one stove. So in one stove we have seen that three executors can work. So each chef or three chefs are can work on one stove. So each chef can use 63 divided by 3 is 21 GB. Okay, I hope this thing is clear. Let's go back to the second scenario where you have, instead of 16 you have 32 cores. Okay, so we'll do the same calculation. Okay, now you have 192 cores. Okay, so if you do the calculation the same way, instead of 3 you can use 6 chef can work in one stove, having the 32 burners, correct? And how much memory is needed? Around 19 GB. Okay, is needed. So I hope you like this video. Okay, so sorry, we have to discuss scenario 3 also, when we don't need much memory for the executor, right? um so this is not useful basically. So your business have to decide, want to increase the burner or chef. Okay, what does that mean is, um so because, see, we have seen that we have the burners, many burners in one stove. Okay, and we have around 90 burners initially. So what is the best idea to make it, to make the task parallel? What is the best scenario, what is the best possible way to do the computation parallelly, is to increase the chefs. Okay, so that without wasting the other burners, because one chef can use only 5 burners, so we are wasting around 12 or 13 burners initially for for one stove. So what we did is, um, to do the task parallelly we have increased the number of chefs. Okay, so I hope you like this video. Thank you.